Imagine a world so distant that sunlight arrives not as a blazing dawn, but as a perpetual twilight, faint and unforgiving. Pluto, the sentinel at the solar system's edge, has long whispered secrets through the void. Secrets of ice that gleams like shattered diamonds, mountains that rise defiant against the cold, and an atmosphere so fragile it seems a breath could scatter it to the stars. For years we've gazed at it with longing, piecing together fragments from afar. But in 2015, NASA's New Horizons pierced that veil, hurtling past at 36,000 miles per hour to reveal not a dead relic, but a realm alive with mystery. Glaciers of nitrogen flowed like rivers across its heart-shaped plains. Haze layers danced in ethereal blue, stretching 1,000 miles high. The images stunned us, igniting wonder and unease. Yet amid the awe, a shadow lingered in the data. Pluto's upper atmosphere clocked in at 65 to 68 Kelvin, far colder than models predicted, a chilling discrepancy of over 20 Kelvin that defied explanation. Gases alone couldn't account for it. Something unseen was siphoning heat into the infinite dark. NASA cataloged the anomaly, but the full truth stayed buried in the numbers, awaiting a sharper eye. That eye arrived in 2022, perched a million miles from Earth. The James Webb Space Telescope, humanity's most exquisite instrument, gazing back at Pluto with infrared precision no probe could match. And what it saw didn't just solve the puzzle, it upended our understanding of worlds beyond the sun's warm embrace, revealing a climate forged not by wind or water, but by a haze that breathes, cools, and transforms. This is the story of Pluto's hidden heart, uncovered at last, and the profound questions it raises about the fragile dance of heat and light at the cosmos's frontier. To grasp the depth of this revelation, we must first journey back to that fateful flyby a decade ago. Launched in 2006, New Horizons carried the weight of decades of curiosity, crossing 3 billion miles to rendezvous with Pluto on July 14, 2015. As it skimmed just 7,800 miles above the surface, closer than many satellites orbit Earth, its instruments drank in a symphony of data. The long-range reconnaissance imager captured vistas of Sputnik Planitia, a basin 600 miles wide, its nitrogen ice rippling with convective cells, as if the ground itself pulsed with slow, geological breath. The Ralph multispectral imager mapped terrains in false color, rusty tholins, complex hydrocarbons born of ultraviolet alchemy, staining equatorial regions in shades of brick and blood. But it was the ALICE ultraviolet spectrograph and the radio science experiment, or REX, that pierced the air. ALICE traced the ultraviolet glow of solar light filtering through the atmosphere, revealing layers of haze that scattered blue wavelengths like a cosmic filter, giving Pluto its ethereal tint. REX, using radio signals bent by the planet's gravity, mapped pressure and temperature profiles from surface to stratosphere. The verdict was clear. Surface pressure hovered at a mere 11 microbars, a whisper compared to Earth's sea level roar. Yet the upper reaches, above 200 kilometers, plunged to those unexpected lows, 65 Kelvin, where even methane freezes solid. Pre-flyby models built on stellar occultations from Earth-based telescopes, like the 2002 event that hinted at warming trends, forecasted a gentler gradient, with exospheric temperatures nearer 90 Kelvin. The shortfall suggested an invisible thief, energy vanishing faster than conduction or radiation could explain. Scientists speculated, perhaps enhanced escape rates, where molecules boiled off into space at 360 kilograms per hour, carrying heat away. But the math faltered. The haze, that delicate veil glimpsed in backlit images, seemed too sparse to dominate. For 8 years, the enigma simmered in journals and conference halls, a quiet thorn in planetary science. Then in 2017, Xi Zhang, a young planetary scientist at the University of California, Santa Cruz, dared to challenge the orthodoxy. What if the haze wasn't a mere byproduct, but the architect of Pluto's chill? His hypothesis, published in Nature, posited that photochemical particles, tholins and their kin, absorbed faint solar ultraviolet, re-emitting it as mid-infrared radiation that bled efficiently into space, bypassing gaseous constraints. It was audacious, counter to the gas-dominated climates of Venus or Titan. Zhang's team predicted a telltale glow. Strong emission peaks at 15 to 25 microns, detectable only by an instrument of exquisite sensitivity. The world waited. And in May 2023, James Webb answered. Perched at the L2 Lagrange point, James Webb unfurled its 21-foot golden mirror like a flower seeking forgotten light. Its mid-infrared instrument, or MIRI, tuned to wavelengths where cold worlds sing MIRI, a collaboration between NASA, ESA, and a global consortium, peers through dust and ice with detectors cooled to 7 Kelvin, capturing photons that whisper of thermal secrets. For Pluto, observed under program GO1658, led by Emmanuel Lelich of the Paris Observatory, the challenge was geometry. At 3.5 billion miles, Pluto and Charon orbit in a tight binary, their signals blending like echoes in fog. Earlier telescopes, even Spitzer, couldn't untangle them. But Webb's resolution, sharpened by its segmented primary, isolated the pair across multiple filters, 15, 18, 21, and 25 microns, over sessions spanning 2022 to 2023. The data streamed back in June 2025, analyzed by an international team including Zhang and Thibault Bertrand, now at the Observatoire de Paris. What they found was staggering. Pluto's thermal light curves pulsed brighter than Charon's rugged terrain alone could muster, with excess flux peaking at 1.5 millianskys in the 18-micron band. Subtracting Charon's contribution, a water ice world scarred by canyons 600 miles long left an atmospheric signature that matched Zhang's prediction to within 5%. The haze wasn't passive. It radiated mid-infrared like a furnace inverted, cooling the mesosphere by up to 30 Kelvin through efficient blackbody emission particles as small as 0.1 microns, suspended in a bimodal distribution, coarse below 50 kilometers, fine above, absorbed UV at rates 10 times higher than gases, then exhaled heat upward, stabilizing the exobase at 1,670 kilometers altitude. This wasn't mere anomaly, it was a feedback loop, where cooling curbed thermal escape while energizing select molecules for hydrodynamic flight. Bertrand's team, in a Nature Astronomy paper dated June 2, 2025, dubbed it haze control, a mechanism where solids, not vapors, dictate energy balance. The emotional weight hit hard in the control rooms at Goddard. After years of probing a frozen ghost, Pluto revealed itself as a thermal artist, sculpting its own survival in the sun's shadow. But as the spectra unfolded, a deeper intimacy emerged, one that bound Pluto not to solitude, but to its eternal companion. Charon, Pluto's largest moon, orbits just 12,000 miles away, locked in tidal embrace, their barycenter dancing in empty space. New Horizons painted it as a world of contrasts, red polar caps bleeding into gray equatorial chasms, a testament to shared history from a giant impact 4 billion years ago. Yet Webb's gaze in 2022 and 2023, using the near-infrared spectrograph alongside MIRI, unveiled a quiet theft. Pluto's haze, that cooling veil, drives atmospheric escape, methane ions propelled by UV-heated particles, streaming at 360 grams per second into the void. But not all flees to infinity. Gravitational tugs intercept 2.5% onto Charon, where solar radiation transmutes it into tholins, those reddish polymers of carbon and nitrogen. The poles glow crimson, not from birthright, but from this aerial gift, a planetary kiss across 19,000 miles. Sylvia Protopapa's team at Southwest Research Institute, publishing in Nature Communications on October 1st, 2024, confirmed it with spectral fingerprints. Carbon dioxide at 4.3 microns, hydrogen peroxide at 3.9, layered atop water ice. These aren't relics. Impacts expose subsurface volatiles. But the reds are fresh, replenished seasonally as Pluto's 248-year orbit tilts its haze toward Charon. Imagine the poetry. Pluto exhales lifeblood to clothe its moon, a bond so profound it echoes our own. Earth and Luna, intertwined in gravitational waltz. Yet this exchange hints at broader rhythms. Webb's 2025 light curves, spanning a full Plutonian day of 6.4 Earth hours, reveal haze opacity varying by 20%, thicker at dawn, thinning under noon's feeble ray. Volatile ices, nitrogen, methane, carbon monoxide, sublimate from equatorial basins, fueling the haze engine, only to refreeze at poles in cycles that sculpt Sputnik planitia cells. It's a climate alive, where haze rises and falls like breath, regulating heat as Earth's clouds do rain. But here's the revelation that quickens the pulse. This isn't Pluto's quirk alone. As Webb pivoted to kin worlds, the pattern repeated, suggesting a universal code for icy frontiers. Titan, Saturn's veiled giant, has long mirrored Pluto in haze's embrace. Its orange shroud a thicker kin to Pluto's blue Cassini's 2004 to 2017 vigil mapped Tholen rains feeding methane lakes. But thermal mysteries lingered. Why does Titan's stratosphere hold steady at 180 Kelvin, despite solar dearth? Webb's MIRI, in observations from July 2023 onward, turned to Titan's limb, capturing mid-infrared spectra at 5 to 28 microns. The glow matched Pluto's, peaks at 21 microns from Tholen emission, cooling the upper haze by radiating 15% more energy than gas models predicted. Tanguy Bertrand's follow-up, presented at the 2025 Lunar and Planetary Science Conference, quantified it. Haze particles, fractal aggregates 100 nanometers across, absorb 90% of incoming UV, re-emitting infrared in a downward cascade that warms the tropopause while chilling above. It's the same dance, solids seizing control from gases, scaled to Titan's denser veil. Neptune's Triton, a captured Kuiper cousin, yields fainter echoes. Voyager 2's 1989 flyby glimpsed nitrogen geysers in pink haze, but Webb's 2024 stare detects subtle 18-micron excess, hinting Tholen cooling tempers its retrograde winds. These aren't coincidences. They're a paradigm shift across the outer solar system. From Pluto's whisper to Titan's roar, haze emerges as the unsung thermostat, forging climates from photochemical fire in nitrogen-methane crucibles. The emotional swell builds here, in this kinship. Worlds once deemed barren now pulse with shared resilience. Their hazes not shrouds of death, but shields of adaptation. And as Webb's archive swells, over 10,000 hours logged by November 2025, the gaze extends beyond, to exoplanets where this blueprint might spell habitability. In the dim orbits of red dwarfs, where 70% of stars harbor worlds, Webb hunts habitable zones cloaked in haze. Take K218b, a 2.6 Earth radius sub-Neptune, 120 light-years distant. Early 2023 NIRIS spectra hinted at methane and dimethyl sulfide, but mid-infrared dips at 15 microns per 2025 MIRI data mirror Pluto's Tholen signature, cooling that stabilizes steamy atmospheres against stellar flares. TOI 700d, Earth-sized in the habitable band of a quiet M-dwarf, shows analogous 21-micron emission, suggesting haze veils, temperate seas beneath. These aren't wild guesses. Models from Shijung's group, updated post-Pluto, predict Tholen formation in hydrogen-rich envelopes, radiating heat to avert runaway greenhouses. The implications cascade like a revelation. Habitability may thrive not in bare skies, but in veiled ones, where organic hazes buffer radiation, cycle volatiles, and cradle prebiotic soups akin to Earth's Hadean haze, rich in hydrocarbons before oxygen's dawn 2.4 billion years ago. Pluto, once demoted outlier, becomes archetype, a prototype for how cold worlds self-regulate, their chemistry whispering of life's primordial forge. Yet amid this awe, a quieter urgency stirs. These discoveries demand we look closer, for in Pluto's haze we glimpse not just a dwarf's defiance, but the fragile ingenuity that might echo across the galaxy, urging us to protect our own thin blue line. As Webb's findings rippled through 2025 scientific corridors, from the American Astronomical Society's January meeting To ESA's mid-year symposium, the human element surfaced, raw and resonant. Tanguy Bertrand, poring over light curves in a Paris observatory alcove, recalled the moment. We expected confirmation, but it's like hearing a world's heartbeat for the first time. Xi Zhang, whose crazy idea birthed it all, spoke in a UC Santa Cruz lecture hall, voice cracking. Pluto taught us humility. We thought we knew atmospheres. It showed us solids can sing louder than gases. The data, peer-reviewed in Nature Astronomy and Astrophysics, painted no hyperbole, just irrefutable spectra, with error bars under 3% at key wavelengths. Yet the emotional core pulsed deeper. In an era of climate peril on Earth, Pluto's haze, self-sustaining, adaptive, mirrors our own stratospheric shields, ozone and aerosols warding flares and frost. It's a call to stewardship, reminding that even at the edge, balance is possible. And as New Horizons, now 60 astronomical units out, relays heliophysics from the interstellar brink, its Pluto legacy endures, bridged by Webb to futures unseen. But what of the shadows NASA once guarded? No buried signals, no classified pulses, just the deliberate pace of science, where raw data from New Horizons' 50 gigabits waited years for Webb's clarity. The hiding, if any, was in the gaps of technology, not intent. Yet the truth, now bared, invites us to wonder, if haze rules these realms, what undiscovered cycles churn beneath Pluto's ices? Subsurface oceans, perhaps, warmed by tidal flexing with Charon, harboring ammonia water brews where tholins seed exotic life. Webb's next cycles, slated for 2026, target polar volatiles, probing for methane spikes that could betray hidden warmth. Until then, Pluto stands revealed, not as enigma solved, but as doorway cracked, its haze a lantern in the long night. In the quiet vastness where sunlight fades to memory, Pluto's discovery bids us pause and ponder. If a world so small, so far, can weave such intricate harmony from cold and chaos, what untapped wonders await in our shared cosmic story? Dive deeper into these frontiers. Share your thoughts below, subscribe for the revelations yet to come, and let this spark ignite your gaze toward the stars. The universe, it turns out, is far more alive than we dare dream. Information updated.